All right, so we're going to look at writing literal equations when we are given a scenario. So we have this in our note packets. We're going to represent the real world scenario with a linear equation. And we have to identify some clues to figure out how we're going to write that equation. So let's zoom in here. And we're going to start with the first one. So we're going to read it through first. So Robert has $78 that he has saved up and wants to eventually buy a new longboard that costs $200. Robert can save $15 per week. Write an equation to represent the longboard purchase. So one of the things that we want to be very, very aware of is the word per. That word is going to mean multiply. Okay, so we're multiplying the $15 by the number of weeks. Okay, so we have to figure out how many weeks it says, which if we look back at our problem, we don't know how many weeks. So that tells us that the weeks is actually going to be our variable. So week is our variable, and I'm going to use W for weeks. I think that makes the most sense to me. So we're looking at how much money he has and how much he's trying to save up to buy the longboard. So his goal is to buy the longboard, which is $200. So that's his total. That's the total that he eventually wants to get. So we're going to put equals $200. And we're going to add up everything that he's saving up. So he already has $78 saved up. So that's like his starting point. So that is where he starts with. He has $78. There's nothing being multiplied to that. He already has that saved up. And he's saving $15 per week. And we said that the 15 is being multiplied by weeks, and weeks is our variable. So we have 15 being multiplied by a variable. And he's saving those together. So we're going to add those together. So we have 78 plus 15W equals 200. And that is our equation. So the next one says a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation to represent their total pay. Okay, so the first thing we look at is, we said the word per means to multiply. Another thing that means multiply is for every. Oops. So this for every is the same thing as per, which means to multiply. So we are multiplying the 300 by the number of machines that he sells. And he already has a base salary of the 40,000. So we're going to start with that 40,000. So we have 40,000 plus, so it says the word plus. So we're going to put a plus sign. Plus a commission of 300 for every machine he sells. And that means per, so 300 times the number of machines. We don't know how many machines, so we're going to use a variable for machine. So I'm going to do 300 times M for machine. And that's going to equal the total pay. And we don't know what the total pay is, so we're going to let that equal our total, and I'm going to use a capital T. So we have our base salary of 40,000 plus his commission, which is 300 for every machine. So plus 300M equals the total. The next one is Lucy has saved up throughout high school to be able to use her savings for purchases in college. She has $6,000 in her account when she goes to college and plans to take out $50 every week. Write an equation to represent the money left in her account. Okay. So one thing that I notice is that it says take out. Okay, she's taking out $50 every week, and taking out means that we are going to be subtracting. Okay, so we're subtracting this $50 every week. Another thing that I notice is we had for every in the one example above this, we have every here. So again, this is the same thing as per, it means multiply. So we're going to be multiplying the 50 by the number of weeks. So we know how many weeks we have, which if we look at it again, we don't know how many weeks. So we're going to use a variable for our weeks. And she starts off with the 6,000. So let's start off with the 6,000. So we have 6,000 in the account, and we are taking out, so we are subtracting, oops, I wanted to use yellow. We are subtracting $50 for every week. So we have $50 for every week. And that's going to equal the total. And we could put it like the example above and put equals T, or we could put it at the beginning here. Either way. So we have 6,000 minus 50W. Okay, let's do another example. So we're going to go ahead and scroll down. So the next example says a busing company charges an initial $50 plus $150 per mile for each rental. Write an equation to represent the cost. This one is actually pretty similar. So I want you guys to do this by yourselves. I will pause. I recommend that you pause the video and I will write the equation in a couple seconds. All right, so you should have an equation that looks like this. So we can have the total cost, you can use C or T or whatever variable you want, equals the $50 plus the 1.5 per mile. Okay, you could have 1.50 with your variable. We don't need to write the 0. If you wrote it like this and did 50 plus 1.5m equals the total cost, same thing. Okay, totally fine. The next one says, Tony has begun eating healthier. Before this change, he weighed 220 pounds. On average, he loses 2 pounds per week. Write an equation to represent his current weight. Okay, so his starting point is the 220 pounds. That's what he starts with for his weight. So we're going to start with the 220. That's our starting point. And he's losing 2 pounds per week. If we're losing something, we know we're subtracting. And then we have this 2 pounds per week. So 2 pounds. And again, we have that per. So we're multiplying that by the variable of weeks. So we have 220 minus 2 times W. And that's going to equal his total weight. Okay, so equals his total weight. You could use T, you could use X, you can use whatever variable you want. And then we're done. The next one I think you guys can do on your own. So go ahead and pause the video and try that one. And I'll write it in a couple seconds. All right, you should have the population is equal to 196,000. And we're adding 1,000 per year. Okay, it is growing. We are adding on to our current population, so we know that we're adding. The next one, it says Miss Cooper is going crazy without having any pets. She decides to adopt 1 pet every month. Write an equation to represent the future number of pets she will own. This one's weird. So our starting point is 0. She doesn't have any pets. So our starting point is 0. And we are adding, okay, that's without having any pets. She doesn't have any. Then we are adding 1 pet per month. So 1 pet per month. Okay, so for every month or per month, we know that we're multiplying. And that's going to equal the number of pets she has total. We could put the P at the front or the P at the end. But if we look at this, do we need to have this 0 here? No. So our answer is P equals 1M. Or we could say P equals M, because we don't need to write that 1 in front of the variable. Okay, so there are a couple tips that are helpful with word problems. So we're going to fill this in. We want to read the entire problem once. Oops. Before we start trying to solve it. And we want to look for words that indicate mathematical operations being used. Okay, so mathematical operations, I'm going to put math operations. And those are addition, subtraction, multiplying, or dividing. So we said that the word per means we're multiplying, forever means we're multiplying. If we're gaining population, we're adding. If we are taking money out of an account, we're subtracting, those types of things. We want to underline or circle anything that is necessary to solve the problem. And I tried to model that for you in the ones up above. And when I noticed something, I made it a point to circle it or underline it. And then we want to compare our final answer, so our final equation, with the word problem to ensure that we are correct. Okay, we want to make sure that it makes sense. If it doesn't make sense, we want to fix it. And then we just wrote some equations given the word problems.